Hello everyone, this is Ghanem Sabih from Process Engineering Tips channel. Today we're going to talk about batch time optimization. We're going to be talking about increasing throughput in a batch process. We're going to be following Schmidt method. And I have a simple example, yet very comprehensive, that is suitable for almost 90% of batch processes. Please don't forget to share and subscribe for more content like this. Thank you.
All right, so we have a process to produce product T by reacting raw material A and B in a batch reactor. This batch reactor, you have raw material coming in, product C coming out. You have a filter, you have a condenser, which is probably tied to a vacuum pump. You have a jacket where you have like steam and cooling water, for cooling and heating purposes. And the steps are charging raw material A, say it's a limited reactant, and then you heat that content into a desired temperature, which could be the reaction temperature. Then you dose raw material B, and as you see, there is no catalyst additions, which means probably self-catalyzed. And as soon as you dose raw material B, the reaction would start. And then you need to maintain basically the reaction temperature. If the reaction is exothermic, then you maintain it with cooling water. If the reaction is endothermic, then you maintain it with steam. Then once all raw material A is reacted, then whatever this excess of raw material B, you could strip. So that's basically, you pull a vacuum, condense the raw material B, or maybe you do like a steam sparge or nitrogen sparge or something like that. Once is that done, then you cool down the content. Then you do an adjustment, something like, for example, for this case, color improvement. So color improvement you could do by adding additives such maybe activated carbon powder. You add there, you mix it up, it does improve the color. Then you filter it out. You filter the activated carbon out. The issue with activated carbon powder is you're probably going to need filtrate for it to be filtered out. And then once it's that done, then you drum out of the reactor, maybe because the customers want that product in drums. Okay, for another 90 minutes. And so the total time is somewhere around 405 minutes, which is like 6.75 hour. Say 7 hours, take for one batch. Okay. So now corporate comes in, said, okay, we're forecasting more demand for product C, and we want to increase capacity. So the proposal is, okay, we're going to invest in a second production line. So getting another reactor, another filter, another condenser, the whole setup. Okay, and mirror production line 1, mirror it with production line 2 to increase capacity. Then you would come up with a different approach, say, okay, let's squeeze as much capacity or throughput as possible from the current system and see if we even need the second production line, or if we could just make it smaller scale so it would be less capex. Okay, so the methodology is you could follow Schmidt method, which is the lean method, by doing a brainstorming session. Say you get together in a conference room with stakeholders. Stakeholders could be the engineers who understand the process, understand the chemistry, understand the recipe. Get operators, who are the people who actually have different mentality than the engineers, different understanding of the process, and they run the process, so they would actually come up with really good ideas. Production specialists could be even like consultants who actually know or have experience with other companies or other similar processes, who understand what technologies out there, because that's really important. So then you get together and you go through the recipe step by step. You go step by step. Each step you ask the team 4 questions. Do I need to do the step? Is it needed? Can I just avoid it? Second is that, can I do the step outside of the cycle time, meaning that can I do it outside the reactor? The third question is like, can I do it in parallel with another step? And the fourth question would be, can I do it faster? So I created an Excel file to capture my ideas and kind of quantify what would be the throughput increase. So I have the steps with the time. So the total is like 405 minutes. And now I'm going to ask myself the 4 questions for each step. So step number 1, which is charging raw material A, does the step, can I avoid the step? The answer is no. You need the raw material, actually. Can I do it outside the cycle time? No, I can't. Can I do it in parallel with another step? Well, if you have multiple raw materials, maybe you could feed them all in parallel, but we have only 2, and one of them would be dosed. So the answer is no. However, I could probably do it faster. I could probably, replace the pump, get like a bigger pump, or maybe the current pump, just maybe change the impeller. And I could say here, change the impeller of the pump to pump it faster. And maybe say instead of 15 minutes, now I could maybe pump it in 12 minutes. Okay, so then I could type here what could be the cycle time reduction. I could reduce it by 3 minutes. Okay. Now, step 2, which is heating the reactor to a desired temperature. Okay. Do I need that step? Yes, I do. Now, can this step be done outside the cycle time? Actually, yes. You could actually install a heat exchanger and heat that raw material coming into the reactor. So then you could eliminate the whole step. So then I would say yes. And I could type, install a heat exchanger or a heater for raw material A, right? And the reduction would be the full cycle time, which is 30 minutes, okay? Step number 3 is dosing raw material reaction. Well, you do need it, of course. And then can it happen outside the reactor? Can it be done in parallel? But can you do it faster? Actually, there are multiple ways you could do it faster. I mean, you could maybe change. You could maybe change the agitation. If the material is viscous, there are newer technologies or newer agitation that suitable more for viscous material and could have like a better mixing around, and this would actually speed up the heat transfer, speed up the mixing efficiency, and could slow the reaction. Maybe you could have a GC, online GC in the reactor, and maybe it would tell you, oh, you already reached the spec that you need. Maybe you could change the utility, make it hotter or cooler. But maybe here for now, I could just say, okay, I'm going to do just control optimization, where I could install like an advanced process control, maybe, that could adjust the parameters and stabilize any variation, and say that maybe reduce it by 10%. Say it will reduce by 9 minutes, okay? So I would say yes, I could do it faster, and I could do it maybe with advanced process control, and I could reduce it by 9 minutes. Now, the fourth step is stripping excess raw material B, okay? So say for this example, we have steam jets as a vacuum, okay? Then you could actually install a one-stage steam jet. Maybe another way you could speed up that process by maybe installing a second step, maybe by installing a second step, a second stage steam jets, or maybe you could change the steam jets to maybe a liquid ring pump, especially if you have like a motive fluid that has really low volatility. like 2-ethylhexanol or something like that, right? Or ethylene glycol or something like that, where it will give you the ability to get a deeper vacuum, and maybe you could even reduce that, say, by 20%. So let's say we could reduce that by 20%. And by the way, we can do we can avoid it. We can't do it outside the cycle time, and also we can't do it in parallel with another step. But we could do it faster and said, okay, we could do it, by 20% less. So that would be 12 minutes reduction. Okay. Now step 5, which is the cooling. Now the cooling need to be done, but it could be done outside this. Could be done, but we would, if we don't have the filtration step, we could actually have installed an external heat exchanger, and we could do it as we pump out the product. But unfortunately, we have a filtration step, so we can't do that. But so this answer would be no, and we can't do it in parallel with another step. But we could do it faster. Also, we could again, we could change the utility, make it more colder. We could have an external heat exchanger in loop, so it will cool it faster. Whatever choice, say you could reduce it by 20%. So this one was around, to remember, that one was around 30 minutes. Say you could reduce it by 20%. So by 6 minutes, you could reduce that step. Okay. All right. Then step 6, which is the filtration. Okay. So basically, this is where somebody would come with the activated carbon powder bag, would open the manway, put it there, mix it up. Then we'll bring another bag for filtrate, and then we'll run it through the filter. And all this could be done actually would be needed, to improve the color. But we could do it outside the cycle time. How? We could actually, instead of the filter, instead of adding a filtrate, we could probably, and instead of adding activated carbon in powder into the reactor, maybe we could have an activated carbon filter. So you could have maybe activated carbon balls, in some sort of filter basket, okay, and you just run the product through it, and in this case, you don't need to add the activated carbon powder. You don't need to add the filtrate, and you could do the whole thing, actually you can do it. You that's actually would do it faster, but you can't eliminate it. Yes, you could actually do it faster. So I would say no here, but you could do it faster and way faster with say like 50% faster, and that was around 90 minutes. So you could reduce around 45 minutes. Okay. Then the last step, which is the drumming, and again, that's actually one of the easiest steps, because you could actually do you could actually convince the customer to get it in bulk, or you could make that drumming faster, maybe having like a 4 nozzles type of drumming station, right? Where you could fill 4 drums in parallel. So then you could reduce the time by 4. So you only have 20%, 25% of the time. So you basically could reduce the time by 79%. Or you could just do, a hold-up vessel. So if I do a hold-up vessel, maybe I could do the filtration in that vessel. So this would allow me to do it outside the cycle time, and it will allow the filtration also to be done outside the cycle time. So that one, I could capture 90 here, and I could capture also 90 there. Okay, actually, the 90 should be here. And now you have multiple ideas. You have a couple of ideas. We increase the impeller size of the feed pump. We preheat the feed coming in. We have an advanced process control to reduce the reaction step. We have maybe an exchanger on the recirculation that could, on the recirculation that could actually reduce the cycle time. And actually, now thinking about it, with a hold-up vessel for the drumming, you could also utilize the same heat exchanger to actually cool. You could make it bigger and cool the product instantaneously, to the hold-up vessel where you're going to do your filtration and drumming. So then, which means step number 5, you could actually do it outside the cycle time. So then you could capture the whole 30 minutes here. So now we see we could actually reduce the cycle time by 264 minutes, which give us a throughput of almost 3 times, the volume that we currently produce. So if we're producing like a 10,000 ton a year, now we are able to produce 2,000. We would be able to produce 28,700 tons a year. So you don't need now a second production line, and you actually gonna produce even more. So, but depend on how much you actually need, then you don't have to, do all the ideas. You could do just some of them just to capture the excess volume or the extra volume that you need, or the extra capacity you need, and you could choose based on capacity and based on complexity of the idea and based on the capex of the idea, right? So then you could do like a prioritization in the workshop itself. You could do the prioritization based on complexity and capex.
I hope you enjoyed the video. If you like the video, please subscribe or share. And if you have any question, I have my email in the bio. You could comment on the video or email me for any questions, and I'll try to reply as soon as possible. Thank you.